Right, so here we go. Here's the first type of some fiber diode array. So we've got a bunch of, we got about 7 per side fiber coupled laser diodes. They're JDSU 5-watt diodes. They go into a 7-to-1 combiner there. Right now I've got it hooked up to quite a weak power supply. I've got about 3 amps of capacity. Can't see the rating plate on it, but it does go up to about 3 amps. The threshold of these diodes is quite a bit less than that. It's under an amp, so hopefully we'll see something. The reason that I'm doing a video is because I've got these silly laser goggles on and won't be able to see any effect from the beam. I was hoping that the CCD in the camera would pick it up. So I don't know if you can see, I've got one end of one fiber there, and I've got another end of another fiber, sort of focus camera, over there. And I don't know which fiber goes to which laser because there's all complicated gubbins going on in here with all the routing of the fibers coming out of the lasers, going around the shop and into the couplers, 7-to-1 couplers here and here. So with all that plumbing happening, I haven't dissected this unit that much in order to not risk breaking a fiber. So hopefully I'll be able to identify them with a little bit of blue on this video. So I'm going to kill the lights in the shop now. I'll leave one light on. Hopefully I'll still be able to see the light on the readings on the power supply. Just oh, by the way, just in case you were wondering, this is Reading Hackspace. We've got some good stuff been happening here the last little while. And there we go, focus camera. We've got new electronics bench and some 3D printer happening, and our workbench, meeting room table, and soldering workstation, laser cutter, and milling machine, and of course the token big friggin' huge copper vapor laser. Anyways, that's not what this is about. So let's hit the lights and see if we can't see something come from these things. So I better turn the bench light on at least so I don't trip over everything and can see the readout on the power supply, but I should see. That shouldn't cast too much light on where I've got the fibers. Okay, cool. So you can see the power supply is set up there on 0. So I'm going to turn the voltage up just a little bit. Turn the current up just a little bit. Now this readout, I sort of trust it, so. Right, so since there's a whole bunch of diodes in series, I expect to get some sort of good voltage reading. Actually, I should probably look at the datasheet again for these before I start turning things on. I can't really remember what is really what here. So, as you can tell, I'm starting to sound a little bit nervous because I've never really worked with infrared diodes before, so I've got the datasheet up on my computer. This is actually the datasheet for the 6.5-watt version of these diodes, so there's going to be a little bit higher numbers than I'm going to be dealing with. But so the forward voltage per diode is 2 volts, so I should be expecting about 14 volts, and the threshold current is about 450 milliamps. So 14 volts, 450 milliamps should be sort of my maximum, or my nominal values and my minimum values for voltage and current. So I'm going to go ahead and turn that voltage right down. Turn the current up until that limit light switches off. Give it a little more ergs until we see something here. Okay, there we go. You see, coming at the end of that fiber, you can see it on the CCD or CMOS sensor or whatever that's in this camera. I can't see it at all with these goggles on, so that's a good sign actually. But there's some power coming out of that end of that diode there. So I just want to see what happens if I put something near it. Right. Okay, so you can see we've got fairly good illumination of the of this bag, basically. Cool. Now, should we go for it? Should I turn this bugger up until it really does something? Actually, you know what I'm going to do first? I should probably set this up. Got my laser power meter here. And hang on, let me just stick this down a second while I untangle the cable with that laser power meter. I'll edit the video after I'm done recording, but I would like to measure some power here. So, just bear with me 1 second. This is the most old school of old school power meters, but I had a fairly good run of doing a comparative calibration between it and Sirius power meter. And that was actually at the Central Laser Facility at Rutherford Labs up in Oxford. So that was a pretty special day. I got to go and hang out with a PhD postdoctorate guy who runs Vulcan, which was for a little while the biggest laser in the world. Anyways, here we go. There's power meter. Got it set on way too high range right now. I'm gonna get it right close to this this little dude here. Hopefully we can see the target spot that it's illuminating on it. I'm not sure that this is really more of an indicative setup than a measuring setup, but either way, to me right now, that's indicating about a watt. So that's pretty special. So, right. So that's it. 10 volts, half an amp in. Don't know if you can see that. There we go. 10 volts, half an amp in. So if I turn that right off, you can see the power meter drops out to 0. Now I should be able to get out of these laser diodes about, 35 watts a side, because these are supposed to be rated as 5-watt diodes, but this power supply isn't going to push that. So I'm going to hit the limit of the power supply, and if I hit the limit of the power supply, the next thing that I'm going to hit is the limit of my power meter, because as you can see, the head and meter, that only goes up to 10 watts. So I'm going to go ahead and slowly turn back up the current on here. So before we were running at 500 milliamps and getting about a watt. You can see, again, just the bare fiber onto the power meter head. Get some good illumination on the CCD, the camera. I'm going to turn that up, go for about 700 and, holy shit, that power meter just spiked like mad. I'm going to go for about, let's see here. That power meter to me, you can see, just to make it clear, it's on the 1000 range, which should be 10 watts. And we're getting about 4 watts out. 10 volts and 650 milliamps. So it looks like I'm going to hit the limit of the power meter. Okay, I just saw a little puff of smoke come from the end of the fiber, so I turned that current right down. So obviously we were dealing with some serious laser gubbins here. Okay, so there we are. We've got some good target illumination, faux de nez shown. You can see that there's obviously been some damage to the fiber because that's illuminating down the fiber there. You can't really see it. Let me focus this camera. Camera doesn't want to focus on that. I wonder why. Okay, there you go. Right, so let's try this again. Let's go. So here we are, turn the current up a bit more. There we are at 4 watts again. Five watts. 6 watts. I've seen 7 watts, 8 watts, 9 watts. And there we go, there's the power meter pegged, and you can see that fiber is really destroying it. So I'm going to have to put something on the end of that. But that's okay, we can do that. I've got a fusion splicer and cleaver at work, so I can terminate this fiber properly, but all I can smell right now is burning glass. So I'm going to do something that's probably a little bit silly and stick some absorbent material in front of that laser there. Just got to find something suitable. What can I put in front of a laser and make burn today? Let's find something, shall we? Let's turn the lights back on and go for a hunt in the hackspace. Right. Doop doop doop. Laser targets, laser targets. Where might I find today a laser target? That's a bit too shiny, that's a bit worrying. Can't seem to think of anything that I can set, well, not fire to, but you know what I mean. Let's see what it does to this whiteboard eraser. Here we go. This Sharpie brand whiteboard eraser. Other whiteboard eraser brands are also available, obviously. You can see it's done some pretty gnarly. Goddamn you, camera, focus, for Christ's sake here. Pretty gnarly damage to the end of that fiber there. But hey ho, we'll go for it anyways. We'll see what happens. I'm a bit curious myself, so there you go. I've got the target set up at the business end of this laser here. I don't know if you got a good picture of it when I was showing it off earlier, but there you go. Again, 7 JDSU diodes. Little mixed power D, my new favorite connector. Some fat rectifier in there. Good for, what, 2000 amps peak or something like that. 7-to-1 fiber combiner, one there, 7 more diodes on the other side. So this module should be good for about 70 watts in total. Right, let me strap these goggles back on. 1 second. We'll see what's really good. Now what I might do, actually, before I start going any further with this, I might snap the end of that fiber off. Should I do that? Yeah, let's do that. Let's just bend that fiber until it snaps. I might put some gloves on quickly, because I know that fiber is pretty gnarly. If you get any stuff in your fingers, it'll probably go right through these gloves, but I'm going to give myself a false sense of security here. That's always nice. Doop-de-doop-de-doop-de-doop. I don't know if you can see what I'm up to here, but I'm about to just bend that like that. And of course, this isn't going to bloody work. There we go. Okay. So I don't know if you saw that. I just bent the fiber basically into a loop until it snapped, and what I'm going to do with this is put this guy straight onto a piece of duct tape and throw him in the bin, because that's, like I said, some pretty gnarly stuff, and it's been damaged on the end. So This is my sharps disposal technique. Just quickly put that straight in the bin so nobody finds it in their finger. And we'll try this again. Right, laser freshly cleaved, you know, with the hackspace precision cleaver. Freshly cleaved bit of fiber. Right, now since I know that I can see the illumination on this, I'm not going to turn the lights off again. I'm just going to turn the power up. Let's see what goes down here. That wasn't even close to the limit of that machine, and that burnt a nice big old hole in the side of that. So I'm going to find a little bit more resilient target, I think. Okay, well, shit. Since we've burnt the target, we need to find a bigger target. Where's some more robust plastic? What can I play with in here today? Right, we got some scraps of black, looks like acrylic here that have been done on our 40-watt laser cutter. So let's see how this thing compares to our 40-watt laser cutter. Now, obviously, that test was about as useful as an useless thing. I'm just going to prop this guy up on this other set of optics for... This is actually a fiber launch that came out of one of the copper vapors, but the lens in it's absolutely mullered, so it's a paperweight right now. So I'll use it accordingly. Sorry, I sort of need both hands to be doing these setups, but that's okay. We won't worry too much. There you go. I've got a little... I don't know if you can see. There's a little black circle of black acrylic in front of that bit of paperweight optics there. Just gonna move this fiber a little bit closer to it. And here we go again in 3, 2, 1. Lots of ergs. Something smoked. Was that the fiber or was that the target? Let's try again just to be sure. I'm going to crank this current right up and see what happens. There we go. Something happened. I don't know if you caught that on the camera. But let's focus. Right. Well, I'll tell you what happened. That burned a big old hole in that thing. And I think it also crispified the end of that fiber. So, right, and that wasn't even peaking it. So, what I'm going to do now is switch the power. This is probably dangerous for these lasers, but fuck it, they can take it. They're good for 8 amps. I'm going to switch that power supply off. Turn up the current limit right to maximum. This is a real test here. I hope you all are watching. I'm going to flick it on for as quick as I can here. Alright, all that did was fizzle the fiber. Right, so I'm going to recleave that fiber. Yeah, right. I'm going to recleave this fiber here. Let's see if we can't try again. And again, snapping the bit that I've snapped off. Slapping that straight on a bit of duct tape. The kindest thing to do while I'm being unkind here with this laser. I don't know, I should probably say something along the lines of don't try this at home, but you probably don't have one of these, so I don't really think I need to worry about it too much. At least don't do this without, something resembling proper safety gear. I've posted the transmission spectra for these goggles on our website at ourlab.org.uk. But I took that from the kind folks over at photonlexicon.com who help me out all the time with these stupid laser projects. Right, so what I've done now, recleave the fiber, put it right up against the target, and I'm going to again just flick the switch on this power supply, which is at full current right now, about 3 amps, but who knows what its turn-on transient looks like. It's probably a crap waveform because it's a cheap Chinese power supply. But anyways, in 3, 2, 1, bang. And again, if you can see, that has just blasted a nice divot in that target piece. I don't know if focus this camera. Yeah, there you go. Cool. So, we've got another working laser here at Reading Hackspace. Not quite as big as our amazing Oxford Lasers CU10 CVL, you know. But hey, every laser helps. That's all, folks.